Hi, everybody. Thank you for tuning in to this session. Today, we are going to do the paper that was set at the South African Mathematics Team Competition in 2023. We have already completed the team competitions for the individuals, where the participants were given 15 questions and they were asked to answer them. The team competitions are different. There are 10 people in a team who will together try to work out 10 problems. They are given 1 hour. I should add that these 10 problems are quite challenging, especially since many of the problems do not uh, engage with the syllabus that is taught at the junior level. That means grades 8 and 9. Often, um, you are expected to know some things which are taught at the higher level, at grades level, in grade 12. So, therefore, it is quite challenging. When you are preparing for these team competitions, you should also try to get a good understanding of geometry, circle geometry, for instance, even if it's not in your syllabus. You can try to read up on that, and also other aspects like, for instance, sequences and and the formulae for the sum and the general term of certain types of sequences, particularly the arithmetic sequences and the geometric sequences. So in this paper, we will come across some of those ideas, and I will try to explain them and try to see how best we can manage those questions. All right, with those introductory words, let me go straight to questions. Okay, let's go to the first question, which is the following. Use the sentence below, printed in italics, and determine how many times each of the numbers 1 to 9 must appear so that the sentence is true. Then write your answer in a sequence separating the values by commas. All right, so you've got, let's read the sentence. We have to count the number of zeros, ones, or yeah, the number of zeros, ones, twos, and so on, all the way up to 9. Okay, in this sentence, the number of occurrences of the digit 0 is, all right, we'll have to put some number there, of the digit 1 is, and so on. Now, just observe that if you put the number of occurrences in the digit 0 is, say, for instance, 5, then when you get to of the digit 5 is, you see, digit 0 is at least 1 because 0 appears in the sentence. The same with 1. Right? This 1 you count, and together whatever number you're going to put in, you count so that the entire sentence becomes true. So the way to do this is to start off by saying, let's give a uh, start off by saying that the numbers from 0 to 9, they occur at least once, and we will write down 1 for each one of them. All right? I've got a table here which I have drawn. All right, so I don't have to go look at the question again. These already occur in that sentence. 0 occurs, so I'm going to put 1 right throughout, and then I'll correct it. All right. It is true that 0 occurs once, and zero doesn't occur anywhere else. Certainly it's not here, and these are at least 1. All these numbers are at least 1. All numbers occur at least once. Because as you saw in the sentence, all these numbers are there, 0 up to 9. The whole sentence was written down. So 0 occurs once and exactly once. Right? Okay, so now let's look at 1. We'll just hold on to 1 for the moment. There are quite a few ones, and these ones are going to change. So let's just hold on with that. Now, suppose we put 2 occurs. If I put down 2 here, right, then it occurs twice. All right. That's fine, but 3 cannot occur. No, there could be no other number which is 2 here, because 2 occurs only 2 times. Now let's have a look at 3. 3, if I put 3 here, I can't put 2. I can't put, sorry. Okay, so I can't put 2 here because it will mean that 2 occurs 3 times. Okay, so I have to put a 1 here. And then we can do it like this. So we can have 1, 1, 1, 2, all ones. So how many times does 1 occur? Let me just. One occurs 1, 2, 3, 4, 5, 6, 7, 8, 9. So what must I put here? I can put 9. So if I put 9 here, then 9, I'll have to change 9 to 2. But the moment I change 9 to 2, then the 2 will now change. So this is wrong. This will have to be 3. So this can't be, because I've got 2 here, right? So I can change 2 to 3 and 3 to 2, but then once again I will have the 2 will be wrong. Okay, suppose I change 2 to 3, and then 3 will be 2 times, counting it, and the 9 is 2. So this seems to be okay. So you got 1, 9, 3, 2, 3 occurs twice, 2 occurs 3 times, 1, 2, 3. But what will 1 occur? 1 will occur. Let's count the ones. So 1 occurs 1, 2, 3, 4, 5, 6, 7. With 7 like that. Okay, let's see if this works now. 0 occurs once, 1 occurs 7, 2 occurs 3 times. Oh. Now, this becomes 1 here. 9, I've taken out 9. So 9 will occur only once, but 7 will occur twice. Sorry, I'm not very adept in handling this contraption. Okay, now let's see whether this works now. So you got 1 occurs 7 times, we counted that, and 7 occurs twice. So therefore 2 does occur 3 times. Right? So 3 will occur twice, yeah, we got there, and all the others number occurs once, and that's fine. So this is the solution. Okay, it's kind of a tricky question, but you have to start assuming that everything is 1 and then make the adjustments. And if you didn't know that you have to do that, then you wouldn't be able to solve the problem. Okay, so let's now get on to the second question. So you can see the last one is 1732. Okay, so that is the answer that we also got. I don't know, there's some argument which led to that, which you could look at. Let's look at the second question. You have 3 two-digit numbers, A, B, B, C, C. All right, so these are like, they're two-digit numbers. It can't be 0, 0. It can be 11, 22, 33, and so on, all the way up to 99. Okay, so I'd like to put these, yeah, okay. All right, so this AA, all these numbers here are multiples of 11. So I can put AA plus BB plus CC. A is a single digit, and this is A times 1, 1, plus B times 1, 1, 11, plus C times 11. Right. 6 times 11 is 66, 7 times 11 is 77. That's what I'm saying here. So 11 is a common factor. Okay, it's given that the sum here is ABC. And this ABC is a 3-digit number. You should have said this. This is not a product. Just like this is not A squared, right? So this is a 3-digit number. So 11 times ABC is equal to that. And this is equal, so we have 11A plus 11B plus 11C. I didn't have to take out the factors. I'll tell you why just now. Because here you got A is in the 100th place. So it's 100A plus 10B plus C. Okay, now let's just get all the A's to one side. I can put the 11 on this side. 100 minus 11 is 89A. I got 11B and 10B this side, so I can make it 10B. 11B minus 10B is B. 11C minus C is 10C. All right, so you got a nice little equation here. And remember, A, B, and C are digits. So it's quite useful to know. Although you got three unknowns here, we can use a logic to decide what's going to happen here. You say C is a single digit. So this thing here is less than 99. Because 10 times the highest value this can have, the highest value for C is 9. The highest value for B is 9. So this thing is less than 99. So if 89A is less than 99, that means A must be equal to 1. A can't be 0 because this is a two-digit number. So A is equal to 1. So what does this mean? It means that B plus 10C, or we can make it 10C plus B, is equal to 89, because A is 1. That immediately tells you what C is. C is 8, and B is 9. Right? This is 10 times 8 plus 9. So this number here, ABC, is 198. Okay. So 11 times, okay, that's the answer. They wanted to know the values of A, B, and C. That gives us the answer. Just to check, you see, 11 times this is 198. So A plus B plus C must be 18, because 198 divided by 11 is 18. And that's it. You got 1 plus 8 plus 9 is 18. Okay, so this is the solution. Okay, so that takes care of question 2. Let's now do question 3. Oh, okay. So I give you a very short answer here. Most of the explanations I have done. Okay, let's look at the next question. Question 3. Initially, A and B each contain 4 positive integers. Also, so A is a set of integers. You've got 4 integers. And we don't know what the integers are. They're not digits, they're just positive integers. That we know, positive. They're natural numbers, in other words. When a certain number is transferred from B to A, now this is A, it's got 4 numbers. And one of these numbers is transferred. And it now is sitting inside here. Right? It's taken out from here. Now, so there's only 3 numbers left here. And this number has got 1 extra number. It says that the average of the numbers in the set A increases by 1. Okay, there is an average here. So let's give us a name to the average. let original average of the four numbers in A we call it some symbol, B, say capital S. Right? And the same thing, let original average of the four numbers in B, we say capital T. All right, now let's see what happens. It says here that the average of the numbers in set A, that's your S now, which we took, right, increases by 1. In other words, this is equal to the new average. No, I'm sorry. Yeah, you have to increase this average by 1. And that will give you the new average. So S plus 1 is the new average. Now, what is the new average? There is a number that was transferred from here. We don't know what the number is. Let's give it a name. We'll call it N. All right. So in actual fact, I had N here originally. Now N is gone from there. So the average of S now. S now has got the original number. It's got 5 numbers now. So you've got the 5 numbers is the sum. Your S is not the average. I should say S is the sum of the 4 numbers originally, right? Okay, and same thing with B. Okay, so if S is the sum of the 4 numbers, that means the average is S over 4, because you have to add the numbers and divide by 4. And that now this average is now 1 increased by 1. But what is the new average? The new average is actually the sum of the 4 numbers plus whatever we. So let the transferred number be N. The number which is transferred from B to A be N. So now you got a new sum, but now you have to divide by 5 because you got 5 elements here. Right? Then likewise, the average of the numbers of the set in B increases by 2. So as far as B was concerned, the sum is B, and the average is T over 4, and that average is 2 more now after this 1 was taken out. You see, your original T consists of the 4 numbers, but now the N is removed, right? And you got fewer numbers, you got 3 now. So this new sum is T minus N, and the new average is T minus N over 3. So this is what you've got here. Okay. So let's try to get rid of the fractions here. I want to solve these these equations. The question is, what was the original difference between the average of the sets A and B? In other words, the question is the difference between the averages. The original average was S over 4 in both cases, and you want to know what was the original difference between the averages. So this is what we need to calculate. Okay, let's just look at these two equations. I've got a common denominator 20. I don't like fractions. Let's multiply right throughout by 20, and you have 5s plus 20 equals s plus n. Oh, well, I'm sorry, 4s plus 4n, because you're going to multiply the right-hand side by 20. So 5 goes into 24 times. So it's 4 into 5 plus s plus n. So it's 4s plus 4n. Okay, so if you bring the s's to one side, 5s minus 4s is s, and you get 4n minus 20. So this gives you your s in terms of n. Now likewise here, I have to multiply the right throughout by 12, yeah? That's your common denominator. And you'll have 3t, and when you multiply this by 12, 4 cancel, plus 24, multiply right throughout by 12. And here you have 4t minus 4n, because you're multiplying throughout by 12. If you bring all the t's to one side, you have t, 4t minus 3t is t, and this is 4n, sorry. Right, so you have 4t minus 3t is t, and yet on this side you got 24 minus 4n. Why do I write s in place of n? Some kind of, this is 4t minus 4n, multiplying the t minus n by 4. So now we need to get s minus t here. This is s minus t over 4. So let's work out s minus t. This is 24 plus 4n. This 24 was on the other side of the equal sign, so that goes there. That's a problem with trying to cramp up all these things that are right here. Okay, let's just clear the space so we don't cramp up anything. Let's apologize for my bad presentations. So we needed to get s minus t, or t minus s, whatever. Let's take s minus t. Right, the 4n minus 4n cancels, and you have minus 44. Minus 20, minus 24. So we are interested in t minus s. It's 44. Right? The original difference is this. So therefore, your your average t over 4 minus s over 4, that's the difference between the two averages, is going to be 11. It's 44 over 4. So that's the answer to that problem. Okay, it's a very unusual way of asking for averages, but this is what is required. At the team level, you are expected to know a little bit more, and the questions are very much deeper. Okay, so let's just clear all these drawings and check to see whether, oh yeah, you got 11 is right at the end. 11 is the answer, but I've done it in some other way. It's advisable for you to check, read that as well. So you have an idea, you'll have two ways of solving the same problem. It might very well be the same principle, but at least, yeah, here the sum of the four numbers. Oh, I see, it's the same thing. Okay, we called it P and Q rather than S and T. Okay. Now, let's get on to the next problem. ABCD is a square in the figure below. Determine angle DAF. There is a question mark at angle DAF. You will see DAF. So we need to work out that one. But it's also given that angle FEC, and these two are shown to be equal. So we need to calculate that one. All right. Now, let's have a look. You see this point here, E, is along the diagonal of a square. Okay. So what does that mean? The diagonal of a square it's got some nice, interesting properties. One of them is these two angles are 45. The diagonals bisect the opposite angles. Right? That happens only in a square and in a rhombus, but generally it's not like that. Also, this is a square, so all these sides are equal. But now, if you look at these two, you will see that they are congruent because you got side, side, angle, angle, and this is a common side. So these two triangles are congruent. The reason for congruency, okay, I'll just put on triangle ABE. ABE is congruent to triangle ABE. Let's read it in the same way, CBE. Right? A corresponds to that. B is at 45, put in the middle, and E. And the reason for that is two sides and to an angle. As you can see, that, and the angle. Okay. So how does that help us? It means that all the sides and all the angles are all equal. This third side, this side must be equal to this side, for instance. Okay, let's give a name to these equal angles. Now we'll go here. These two angles, let's call it X. Then this becomes the exterior angle of this triangle. X plus X is 2X. So it's the exterior angle of this triangle. Now, if you follow this through, you've got an alternate angle here. So this angle here will have to be 2X. Now we know that these two triangles are congruent. So if that is 2X, this is 2X here also. These two triangles are congruent. And there you have it. You've got 3X is 90 degrees. So X is 30 degrees. So the trick is to solve the angles X and try to what we call diagram chasing. You go and find something else and find something else. But the important thing is that these two triangles are congruent, and it's always a property. If you take a point on a diagonal and you create these triangles, you'll always get two congruent triangles. All right, and this for the same reason, two sides and two triangles. This is a random point on this diagonal. These two triangles are congruent, so it'll happen on every point. Okay, so that answers that question. Let's just clear the drawings. Okay, I think we did it the same way, and the answer is 30 degrees. Okay, now we go to question 5. Mother came home and saw a broken vase. She immediately questioned the 4 children, who replied as follows. Okay, Alex says, it wasn't Brian, it was Daniel. Brian says, it wasn't Charlie, it wasn't Daniel, and so on. Each one makes a statement about who possibly broke the vase. Nice. Interestingly, their names start with A, B, C, D. So that's a nice way of naming them. So you'll name these guys A, B, C, D. All right. Now, mother knew that each of them made one true and one false statement. Now, this is very important. So one statement was true and one statement was false. The question is, who broke the vase? Right. Now, what I've done here in this little diagram is I've captured the information that was given in this diagram. And there's so much of information given, but I captured it quite nicely. So A, B, C, D are the 4 people. Okay, let's just distinguish them. So okay, now A says it wasn't Brian. So A says, when it comes to Brian, he says no. N means no. A says it wasn't Brian. It was Daniel. So A says, as far as Daniel is concerned, it was yes. And like that, now I've captured the information. So B said, evidently said, both C and D were not the criminals. And you can see Brian said it wasn't Charlie, it was Daniel. And like that, the others are captured here. Very nice way of doing things. All right. Now, from this point onwards, we have to prove by contradiction. In other words, I'm going to assume something. Suppose it was who broke the vase. So let's start with Alex. And we suppose that right now, at this point, the logic kicks in. We are making an assumption that Alex broke the vase. So let's see what happens to this table here. So Alex did break the vase. Let's not worry about what Alex said. But we see a C said that B broke the vase. Right? But we are saying that Alex broke the vase. So C is actually lying. Right? When he says he broke the vase. So therefore he must be speaking the truth. The other one, because there's one lie and one truth. So this truth says C did not break the vase. So that is true, because this is a I'm sorry. Suppose Alex broke the vase. Yeah, no. Okay, then C said that B broke the vase, and that's false. So therefore, this is true. That means D did not break the vase. Okay. So D did not break the vase. And so B spoke. Yeah, oh, wait a minute. Let's not look at that. You see, what did B say? B said that C didn't break the vase, and that's true. And B said that D didn't break the vase, and that's true. So B made two true statements here. That can't be. So I should have looked at this. So if Alex broke the vase, then B made two statements, and that's a contradiction. So the Alex did not break the vase. I'm not going to write all that. So Alex did not break the vase. So one of the others broke the vase then. Therefore, B, C, or D broke the vase. Okay, so Alex did not break the vase. So let's suppose that B broke the vase. We say vase, but some people say vase. I think Americans call this thing vase. Americans always do the wrong things. Now, suppose B broke the vase. Okay, so now we have that A did not break the vase. So nothing is said about A here. But suppose B broke the vase. That means C lied. No, C spoke the truth. No. B broke the vase. We are assuming this part here now. So if B broke the vase, that means C is so if B broke the vase, that means B again is lying twice here. No. He's speaking the truth twice here. Because he says C did not break it, D did not break it. And here we are saying that he broke it. So both of them are true, and that can't be. So again, B did not break the vase. Okay, let's try D. Suppose D broke the vase. Okay, so now we can't go to that one now because D broke the vase, and that means that D is saying that neither B nor C broke the vase. And that's quite true because he broke it. Right? And he says that neither B nor C broke the vase. Both of them are true, and that's also false. So even this is false. So D did not break the vase, B did not break the vase, so therefore C broke the vase. Let's see if is any contradiction there. Okay, C broke the vase, right? So A says that B did not. Okay, true. This is false. B says that C broke the vase. B did not break the vase. This is false. And that is true because C broke the vase. And C broke the vase. He said that B broke the vase, which is false. And he also said that D did not bring the vase. So both of them are correct. And so on. All right, so we have the answer to that is C broke the vase. It's a logical problem. And the way we do logical problems very often is you assume something and come to something which is impossible. And then you say the assumption is false. That is why I said, suppose Alex broke the vase, we came to some false conclusion, and we said, therefore, the original assumption is false. Like that, we came to each of those three people and we saw that in each case we came to something which is impossible. So in all those cases, they did not break the vase. All right. So C was the only one who stood out. Okay, so let's just get on to the next problem. Oh, okay. The answer is yeah. I don't know. I'll put the question here as well. All right. Okay. Question 6. We are at question 6 now. A fraction f in its simplest reduced form is given by f, which is x over y. Simplest. In other words, you can't cancel anymore. All right. X and y are positive integers differing by 19. So in other words, we can say that y is x plus 19. Okay, so what do we have here? We have 16. Now they say they got an inequality here. And the question is, what is the maximum value of x plus y? Okay, let's just put that question in freeze, deep freeze for the moment. Let's see what this thing says here. 16 over 27 is less than f. F is x over y. And x and y differ by 19. So this will have to be 19. Obviously, the denominator is larger because this is a proper fraction. It's lying between two numbers which are less than 1. So you'll have to have the x at the top and x plus 19 at the bottom. Otherwise, if you turn it around, then you get a number which is greater than 1. You can't have a number greater than 1 sitting between two numbers which are both less than 1. So this is 11 over 18. Okay, now let me just cross multiply this part here. And you have 16x, 16 times x, 16 times 19 is 304, is less than 27x. I'm assuming this and I'm trying to make some conclusion. And then you have 11x this side, so you got, if you subtract 27x minus 16x, 11x is greater than 304. Now x is a integer, positive integer. And what are the values? That means x must be greater or equal to the first multiple of 11 beyond 304 will be 308. You want 3 plus 8 to be 11. So 11x is greater or equal to 308. So x is greater or equal to 28. Why did I do this? I could have said that x is greater than 304 over 11, and then I would have got 27 and 7 over 11, and it's an integer. So which integers are greater than 27 and 7 over 11? I could have done it that way. I think that's a better way of doing it. It's all the numbers which are starting from 28 onwards. All right, so now you've got a restriction on x. Let's look at the other inequality. X over x plus 19 is less than 11 over 18. Again, we cross multiply with 18x is less than 11x plus 209. 11 times 19. All right. So that means that 7x is less than 219. 209. 11 times 19 is 209. And x is less than, divide both by 7. This is 29 and 6 sevenths. 203 is 29 times 7. So therefore you have that x is less than or equal to 29. Because it's an integer, and x, which integers satisfy this? All these integers. So you have that is greater or equal to 28 is less than or equal to 29. So the only two possible values for x. X is 28 or 29, right? Now, if therefore your fraction is the, the x over y will be 28, and this is 19 more, so that's 47, or 29, and this is 19 more, that'll be 48, right? So these are the only two possibilities. So therefore, x plus y is 28 plus 47, 76. You want to know something about x plus y or 77? But you want the maximum value of x plus y. So therefore, x plus y must be 77. That's the larger of the two values. Right. So we could have answered that question like that. Actually, we should say maximum value. Maximum value of x plus y is 77. Okay, so that takes care of that problem. These questions are set for a group of professional mathematicians, and the teams, about 50 teams, take part from all around the country. So there are about maybe 500 people who are sitting and trying to work out these problems. And then the team which has got the highest number of points wins. They give you 100 points, marks for each question, right? So if you get it right, you get 100 marks. So the maximum marks you can get is 1,000. Right? So, and I can tell you that I don't think in the many years I've seen this, maybe 30 odd years, there's not once did any team get all right. So the team questions, and that includes a lot of people who are excellent over the years, but it's a whole team, you see. They were just given 1 hour to answer this. So they make it as difficult as possible. All right, so we said that x plus y, its largest value is, oh, there it is. 77 is the correct answer. Okay, let's now get to the next question. Question 7. Okay, we'll do this. Well, I think yeah. Okay, question 7.